Okay, listen, dear students. Let's see the first question. Very easy only. Glycerol. Glycerol. Just write that given structure in vertical form. Okay, this is glycerol structure. So this glycerol contains what type of alcohols present? It contains the OH group is attached to primary carbon. That's why it is called primary alcohols. And this OH group is attached to secondary carbon. So it contains two primary alcohols and one secondary alcohol is present. Okay, one secondary alcohol. It does not contain tertiary alcohol. It does not contain tertiary alcohol. It does not contain tertiary alcohol. Okay, students. So the answer is third option. Okay, an example for polyhydric alcohol. Let's see the second one. Methyl alcohol. First option, methyl alcohol, molecular formula CH3OH. So it is monohydric alcohol. One OH group is present. Okay. Next, neopentyl alcohol. Neopentyl. The second neo. Okay. Neocarbon. Neocarbon means what, dear students? A carbon is attached to four groups. Neopentane. CH3 bond CH3 bond CH2OH. This is neopentyl alcohol, neocarbon. When carbon is attached to four alkyl groups or four carbons is called a neocarbon or quaternary carbon. It having one alcohol at primary, that's why it is a monohydric alcohol. Neopentyl alcohol. Next, secondary butyl alcohol. Secondary butyl alcohol means butane means four carbon atoms are present. CH2 bond CH OH. At secondary carbon OH group is present. It is called secondary butyl alcohol. It is also have one OH group is present. It is monohydric alcohol. Now the fourth one, answer is fourth one. However, we don't know the structure of. If you don't know the structure of mannitol, also it belongs to polyhydric alcohol. So mannitol. Mannitol is a polyhydric alcohol. Polyhydric alcohol. Why? Because it has 6 OH groups are present. Mannitol structure, let's see. Six. Here OH group is present. 6 carbon atoms. 2, 3, 4, 5, 6. Here OH group is present. One OH, another OH, OH, and OH. So total it has 2 primary alcohols and the remaining 4 secondary alcohols are present. So total 6 OH groups are present. Okay, what is the meaning of polyhydric alcohols, dear students? Polyhydric alcohols means more than 3 OH groups are present. Such compounds are called polyhydric alcohols. Such compounds are called polyhydric alcohols. Okay. Okay, now the answer is fourth option. Now let's see the third question. Third question, dear students. What is the third question? Which one of the following is secondary alcohol? Secondary alcohol they are asked. Okay, pentane 2-ol, 2-pentanol means the answer is fourth option. It's very clear. Propane 1-ol, OH group at first carbon. First carbon, that's why it is primary alcohol. And 2-methyl propane 2-ol. Let's see the first option. 2-methyl propane 2-ol. This is 2-methyl propane 2-ol. It is a tertiary alcohol. Next, propane 1, 2, 3 carbons. Here 1, 2, 3 carbons. That methyl group is at present second carbon. That's why it is called 2-methyl propane 2-ol is tertiary alcohol, and propane 1-ol is primary alcohol, and butane 1-ol 1, 2, 3, 4 OH group. It is also primary alcohol. Let's see fourth option, pentane 2-ol. This is pentane 2-ol. It is secondary alcohol. Okay, your answer is fourth option because we have to identify secondary alcohol. Okay, students, let's see that fourth question. Ethyl alcohol is manufactured from ethene. Ethene, CH2 double bond CH2, ethene. How we are preparing ethene is converted into ethyl alcohol. CH3, CH2, OH. Let's see what are the suitable conditions. The suitable conditions is the hydrolysis we are doing. Hydrolysis in the presence of concentrated H2SO4. Okay, then we are getting ethanol because the H plus and OH minus ions we are adding. The H plus ions added at any one of the carbon because it is a symmetrical alkene. Then we are getting, you have to add H plus ions according to Markovnikov rule. You have to add hydrogen at any one of the double bond carbon and OH at adjacent carbon you have to add. Then we'll get ethene. Ethene is converted into ethyl alcohol. Ethene is converted into ethyl alcohol by the addition of hydrolysis of water in the presence of concentrated H2S4. So third option is correct. Okay, students. Now let's go for next question. Fifth question. Which of the following pairs can be used as a starting material for synthesis of 2-phenyl pentanol? Okay. So what is the product do you want, dear students? 2-phenyl pentanol. 1, 2, 3, 4, 5. At second carbon, phenyl group is present as well as a OH group is also present. This name is 2-phenyl pentane 2-ol, pentane 2-ol. This compound we have to synthesize. How can we synthesize this compound? Let's see. This compound we can synthesize bromobenzene. Bromobenzene is treated with magnesium metal in the presence of dry ether, forms C6H5MgBr, phenyl magnesium bromide. Magnesium bromide. Okay, students, this is Grignard reagent. This phenyl magnesium bromide reacts with ketones, acetone, or 5 carbons containing ketone. At the ketone functional group at present at a second carbon only. It reacts with 1, 2, 3, 4, 5. Pentane 2, 1. followed by hydrolysis, it will be attack at second carbon, then we are getting 2-phenyl pentane 2-ol. So the starting materials are bromobenzene and pentane 2-ol. See, 1, 2, 3, 4, 5. So phenyl bromide or bromobenzene, and pentane 2-one are the starting materials we have to use for the synthesis of 2-phenyl pentane 2-one. How we are preparing? First step, that phenyl bromide or bromobenzene treated with magnesium metal in the presence of dry ether, we are generating Grignard reagent. That Grignard reagent is reacts with pentane 2-one followed by hydrolysis. We are getting 2-phenyl pentane 2-one. So it's very, very important. So Grignard reagent application. So your answer is a third option is correct. Now this sixth option or sixth question already we have discussed in yesterday class only we have discussed it. Okay, what is that? Starch is converted into maltose. What is the enzyme we are using, dear students? Diastase enzyme we are using. Diastase enzyme we are using. Starch molecular formula C6H10O5 and times it is a polymer. Okay, polycarbohydrate is the polymer. So n moles on hydrolysis in the presence of diastase enzyme, then produce C12H22O11. C12H22O11. N moles of C12H22O11 it will produce. This is maltose. Okay, what is the enzyme we are using? The starch is converted into maltose, diastase enzyme we are using. Again that maltose is converted into glucose. We are using maltase enzyme. That glucose is converted into ethyl alcohol. We are using gymnase enzyme. Okay, maltose converted into glucose. We are using maltase enzyme. Okay. Next, let's see the next question. Seventh question, let's see, dear students, it's very easy and important also. The catalyst used for the conversion of water gas and hydrogen into methyl alcohol. What is the water gas, dear students? Water gas composition already in first piece we are studied. CO, carbon monoxide plus H2 is called water gas. This CO plus H2 is nothing but CO plus 2H2 in the presence of zinc oxide and chromium trioxide, Cr2O3, okay, converted into methanol, CH3OH. Methanol it forms. It is the industrial method for the synthesis of methanol, and the important catalyst is zinc oxide and chromium trioxide. It is selective catalyst, converts water gas into methyl alcohol. So fourth option is correct. Now let's see that eighth question. When ethyl alcohol is distilled with bleaching powder, and water, then chloroform is obtained. In this reaction, how many number of moles of bleaching powder is we are using for the preparation of 1 mole of chloroform? First, bleaching powder. What is the bleaching powder formula? CaOCl2. This bleaching powder on hydrolysis in the presence of water is converted into calcium hydroxide. CaOH twice plus Cl2. Okay. Now this produce chlorine. This chlorine acts as a oxidizing agent. It acts as a oxidizing agent. First, it reacts with ethyl alcohol. Is nothing but what this reaction, dear students? Haloform test. Haloform test. Okay, already we know that haloform test. This alcohols, in alcohols only ethyl alcohol, in primary alcohol ethyl alcohol, and in secondary alcohols terminal secondary alcohols. Terminal secondary alcohols gives positive test with the haloform test. Okay, it reacts with chlorine. This first 1 mole of chlorine, it is 1 mole. Okay, first mole, it is used for the, it acts as oxidizing agent. It oxidizes ethyl alcohol into acetaldehyde, CH3C double bond OH. This acetaldehyde has terminal methyl ketone. Methyl ketone group is present. It has methyl ketone, keto group. Okay, plus 2HCl. Okay, students, it's very clear. Now, this CH3C double bond OH acetaldehyde reacts with 3 moles of Cl2 and converted into CCl3C double bond OH trichloroacetaldehyde. This trichloroacetaldehyde is on hydrolysis. It is on hydrolysis. This bond will be break, is converted into CHCl3 plus HC double bond OH, formic acid. This is chloroform. It is how many moles are forming? 1 mole only formed. So this 1 mole of chloroform utilized for the formation of 1 mole of ethyl alcohol. 1 mole of ethyl alcohol, it utilized 3 moles of 3 plus 1. 4 moles of chlorine it utilized. So we want to produce 4 moles, means it is 1 mole of calcium oxychloride produce 1 mole of chlorine. It produces 1 mole of chlorine. Okay, so how many moles of chlorine do you want? So we want 4 moles. Then it produces 4 moles of chlorine. Okay, students. So for the formation of 1 mole of chloroform, 1 mole of chloroform from ethyl alcohol, it required how many moles of bleaching powder? It requires how many moles of bleaching powder, dear students? Here 4 moles of bleaching powder is required because it utilizes 4 moles of chlorine. It utilizes how many moles of chlorine? 4 moles of Cl2. This 4 moles of Cl2 is formed from 4 moles of calcium oxychloride, CaOCl2. That's why it's very important reaction. In the same way, instead of chloroform, iodine is required. How many moles of iodine is required? 4 moles of iodine. Iodine is produced from potassium iodide. Then how many moles of iodine is required? Potassium iodide is required. So 8 moles of potassium iodide is required. Ki. Like different kind of questions they will ask. Haloform test. This is the important reaction. It is a haloform test. Haloform test generally given by the methyl ketones, methyl ketone groups. Along with methyl ketone groups in alcohols, ethyl alcohol and terminal secondary alcohols. Terminal secondary alcohols means this OH group is present at secondary carbon. See, these are also secondary carbons, but here except this. These are also secondary carbons only. At OH is present, but it is not a terminal secondary alcohol. Okay, internal secondary alcohol. Terminal secondary alcohols also gives a haloform test when reacts with halogens in the presence of base. First 1 mole of halogen oxidizes terminal secondary alcohol or ethyl alcohol into ketone groups, methyl ketones. Then the remaining 3 moles of chlorine halogens are converted into trichloro compound, and these further hydrolysis convert into haloform, either chloroform or bromoform or iodoform it will produce. Okay, it is very, very important. Total how many moles of halogens are required? 4 moles. That's why 4 moles of bleaching powder is we are utilizing for production of 1 mole of chloroform. Okay, let's see next question, ninth question. Methyl alcohol treated with PCl5. What is A, dear students? 1 mole of PCl3 reacts with 3 moles of methanol to produce 3 moles of methyl chloride, CH3Cl plus H3PO3. This is A. Okay, this A reacts with KCN followed by hydrolysis. A is CH3Cl reacts with KCN, is undergoes SN2 mechanism, nucleophilic substitution reaction, then forms CH3CN, methyl cyanide. This cyanide is followed by hydrolysis. We are getting acids. Is converted into COOH, carboxylic acid. Now C double bond OH. So what is this name? Acetic acid or ethanoic acid. Your final product is acetic acid. This is C. Okay, students. Let's go for 10th question. It's very easy only. The question is very big, but we can solve this question very easily. 10th one. Let's see that an organic liquid A contains hydrogen and oxygen atoms are present. It has a pleasant smell. Okay, this is organic compound A, dear students. Its boiling point is 78 degrees centigrade. Okay, now it treated with concentrated H2SO4. Concentrated H2SO4 and forms a compound, a colorless gas will be produced. That is, let it may be compound B. This B is treated with either bromine water or alkaline KMnO4. Okay, what happens? It is test for unsaturation. It is a brown color. It is a pink color. This color will be disappears. Okay, color disappeared. Means it is a unsaturation test. Test for unsaturation. So test for unsaturation means the B should be alkene. If alkene concentrated H2SO4 means A should be alcohol. Loss of water. Okay. Now what is A? What is A, my dear students, among the options? The A is fourth option, ethyl alcohol. C H3 bond CH2 bond OH. Okay. Now the B is CH2 double bond CH2. The product bromine water, the product is CH2Br and CH2Br. And alkaline KMnO4, the product is ethylene glycol. Ethylene glycol. Okay. Now one more hint also they gave. One mole of this gas can also takes 1 mole of H2. 1 mole of H2, the organic liquid A is asked. Okay. See this CH2 double bond CH2 reacts with 1 mole of H2. In the presence of nickel catalyst or nickel platinum or palladium, they produce CH3 bond CH3. That's why B should be alkene. B should be alkene. So if B is formed from A should be alcohol. Among the given alcohol is fourth option. Among the given alcohol is a fourth option, that is ethyl alcohol. So like, see, while reading the question, we feel this much big question, how can we solve? What they gave hint, will be confused. But just read the question carefully, we can identify very easily. So, a organic liquid A, upon heating, treated with concentrated H2S4. Concentrated H2S4 is dehydrating agent and forms one compound B. It is a colorless gas. Means ethene lower carbons containing alkenes like 2, 3, 4 carbons. They are in existing gaseous state only. Okay, this B, that compound is decolorizes when it bromine water or as well as alkaline KMNO4. Means immediately we will get idea that compound is alkene. So that alkene is formed from alcohols and treated with concentrated H2SO4. Concentrated H2S4. Then definitely we will get this answer. That is fourth option. Okay. Now let's see that 11th question. A compound reacts with sodium and liberates hydrogen and oxidation to give ketone. What is the formula of the compound they give? Okay, a compound, let it be A. This is the compound is treated with sodium metal and liberates hydrogen gas. Okay, whatever it may be, first liberates hydrogen gas. If hydrogen gas liberates means according to this A, maybe it may be OH group, alcohols or acids, we will thought. But A on oxidation, A is on oxidation produce ketones. Ketone is formed. Automatically what we will thought? This A must should be alcohol only. What type of alcohol? It should be secondary alcohol. It should be secondary alcohol because secondary alcohols converted into ketones. Primary alcohols converted into on mild oxidizing agent, converted into aldehydes. A strong oxidizing agent converted into acids. Okay, that's why ketone they form. Means it must should be A must should be secondary alcohol only. Secondary alcohol. Finally, we are decided. Among the given options, which is secondary alcohol, dear students? See, this is secondary alcohol. The remaining options all are primary alcohols only. Okay, your answer is second option. Okay, just it's very easy only. Just we have to clean observation is very very important. Okay, let's go for next 12th question. 12th question, dear students. Iodoform cannot be prepared from. Iodoform test means haloform test only, ma. The 12th question, haloform test. In which iodine we are using. So if iodine used, then it is called a iodoform test. The haloform test can be given by acetaldehyde, methyl ketones. Methyl ketones means what, dear students? Like these compounds. CH3 C double bond O group containing compounds. Methyl ketones. Next, in alcohols, ethyl alcohol. Ethyl alcohol. Already this application we did. And second one is terminal secondary alcohol. This is terminal secondary alcohols. Gives haloform test or bromo. Haloform, that halogens are chlorine, it is called chloroform test. It is bromine, bromoform test. It is iodine, iodoform test. Okay, among that which does not gives, this methyl alcohol does not gives. So your answer is, it does not gives this remaining, this it will gives, it will also gives. Okay, so your answer is first option is correct. First option, methanol does not gives a iodoform test. Okay, let's see that. 13th question. Iodine is produced from ozone, reacts with moisture Ki. It is used to convert ethanol into CHI3 into Ci3CHO. How many number of moles of ozone is required, they are asked. Let's see here. This is also iodoform test application only. The 13th question. Ozone is oxidizing agent. It oxidizes Ki, potassium iodide. Moisture Ki means in presence of water. Is converted into KOH. 2 moles plus I2 plus O2. Okay, so we have to balance this equation. Here iodine, I2 is forming means 2 moles of Ki. Okay, 2 KOH. Hydrogen atoms are balanced. Oxygen atoms also 4 are present. Here 3 plus 1, 4 are present. Okay, 1 mole of ozone, 1 mole of O3 produce 1 mole I2. 1 mole I2. It is very clear. Now this CH3 CH2 OH. This ethyl iodide, first 1 mole reacts with 1 mole of iodine is converted into CH3 C double bond OH plus 2HI, and this is 1 mole, and another 3 moles of iodine reacts with acetaldehyde, produce Ci3 C double bond OH. This is upon hydrolysis, we are getting CHI3 iodoform plus formic acid. Okay, students. Now here how many moles total? 4 moles of iodine. 4 moles I2. If 4 moles of I2, how it will forms? Here 1 mole only, you must multiply the above equation with 4. Means 4 moles of ozone produce 4 moles of I2 when reacts with 8 moles of Ki, 8 moles of potassium iodide. Here they are asked with respect to ozone only. So how many moles of ozone is required for the oxidation of excess of potassium iodide, moisture potassium iodide? Because we want 4 moles of iodine, that's why 4 moles of ozone is required. So the answer is third option is correct. Okay, so the same kind of question we did with the bleaching powder. Calcium oxychloride is known as a bleaching powder. Okay, let's see the 14th question. Okay, students, 14th question also very easy. Just we have clean observation is very important. 14th question. A compound molecular formula X molecular formula, what they gave, dear students? This should be C3H8O. Okay, X gives iodoform test. X is on giving iodoform test. Okay, and iodoform test on oxidation. That again X is on oxidation with K2Cr2O7. The oxidation with acidified K2Cr2O7, X gives Y. This is on oxidation with K2Cr2O7 and produce Y. Okay, and Y also gives iodoform test. It is also giving a iodoform test. See, if it is giving iodoform test means only this information we will get doubt that X mass should be either alcohol or ketone, terminal methyl ketone. If it is X is it is converted into, it must should be Y is terminal methyl ketone, is on oxidation produce a secondary alcohol. This X must should be secondary alcohol. Then only that secondary alcohol oxidation with K2Cr2O7 and produce a ketone. This Y should be ketone. Y should be ketone. What type of ketone? Methyl ketone. And however, 3 carbon atoms only present. It is 3 carbons containing ketone. 3 carbons containing ketone means CH3, C double bond O, CH3. Acetone only, methyl ketone. Okay, that's why it gives iodoform test. And this is the secondary alcohol. Now, okay, why we get idea? But what about the X? The X is must should be secondary alcohol. 3 carbons containing secondary alcohol is CH3, CH, OH, bond CH3. Isopropyl alcohol. It is a isopropyl alcohol or propane 2-ol. Propane 2-ol. What are the X and Y they asked? So the X is isopropyl alcohol, the Y is acetone. Y is acetone. Now the answer is second option. Answer is a second option. Okay, students. Let's see the 15th question. Victor Mayer test. Victor Mayer test. Okay, what is Victor Mayer test, dear student? This test is used for the identification of primary, secondary and tertiary alcohols. Okay, primary, secondary and tertiary alcohol. The Victor Mayer reagent is if the alcohol ROH is treated with first HI, hydrogen iodide. The second one is treated with silver nitrate, AgNO2, and the third one is treated with HNO2, nitrous acid. If primary alcohols, okay, if primary alcohol gives red color, secondary alcohol gives blue color, and tertiary alcohols no reaction or no color. Okay, students, just like Lucas reagent concentrated HCl and ZnCl2 used for the identification of primary, secondary and tertiary alcohol. In the same way, Victor Mayer test is also used for the identification of primary, secondary and tertiary alcohols. So whenever primary alcohol gives red color, secondary alcohol gives blue color and tertiary alcohols no color. So here red color is forming means the alcohol is belongs to primary alcohol. Okay, let's go for next question. Okay, 16th question. Let's listen, dear students. This already in level 2 we did. This alcohol is converted into alkyl chloride. 4 moles are forming when they treated with PCl3 plus PCl5. Its ratio we need to find out. This is 4 moles of alcohol. Out of that 3 ROH, 3 moles of alcohol reacts with PCl3 and produce 3 moles of alkyl chloride plus H3PO3. And the remaining 1 mole alcohol reacts with 1 mole of PCl5, produce alkyl chloride plus POCl3 plus HCl. Okay, now what is the ratio? 1:1 ratio. 1:1 ratio of PCl3 and PCl5 reacts with 4 moles of alcohol, produce 4 moles of alkyl chloride. Okay, the answer is first option. Second option is correct. Now let's see the 17th question. The vapors of an alcohol is passed over red hot copper tubes, produce an alkenes. See the primary alcohols. Primary alcohol passed through copper tubes produce aldehydes. Secondary alcohols produce two ketones. And tertiary alcohol produce two alkenes. So among that, what is the alkene? What is the alcohol we are using? Tertiary alcohols. So already this is direct reaction. This reagent also copper. Reagent also copper metal is also used for the primary, secondary and tertiary alcohol. Because the primary alcohol, the products are aldehydes. Secondary alcohol, the products are ketones. Tertiary alcohols undergoes dehydration, produce alkanes. This type of question also came in level 2 exam. Level 2. Okay, let's go for 18th question. 18th question, Seema. It's very important. Ethyl hydrogen sulfate. CH3 bond CH2 bond O, S double bond O, bond OH. Is reacts with excess of alcohol. Reacts with excess of alcohol. Then this alcohol acts as a nucleophile. Okay. Then because at this carbon, this sulfate group is acts as a good leaving group, O minus, and here forms positive charge, then produce ROH bond O C2H5 and loss of H plus RO bond C2H5. Ethers are the products. Okay, ethers are the products. This O minus and this H plus converted into again sulfuric acid will generate. Okay, the answer is ethers. Diethyl ether. So the excess of alcohol also must should be C2H5. C2H5OH, ethyl alcohol. Then we will get diethyl ether. Okay, students. Now, 19th question, let's see. C5H11OH. OH has how many primary alcohols? Number of primary alcohols we have to identify. The answer is 4. 4 primary alcohols will produce. See, let's see what are the 4 primary alcohols. 5 carbons means 1, 2, 3, 4, 5. It is primary alcohol. This is one. And the second one is just one, change the methyl group position. Means 4 carbons you have to take in a straight chain. And the OH. Now let it at end. This methyl group came. This is second type of primary alcohol. And again you have to take 4 carbons in a straight chain. And the methyl group position you have to take at second. This is third one. And the fourth one is quaternary isopropyl neopropyl alcohol. This is a fourth one. So like 4 primary alcohols are present. Okay, students. Let's see next question. The 20th question. It's very clear. Methanol is industrially prepared. Methanol, how we are preparing industrially? The reduction of CO and H2 is nothing but water gas. This water gas is treated with in the presence of ZnOCr2O3 and forms CH3OH, methanol. This is the industrial synthesis of methanol. Industrial method for the synthesis of methanol from water gas. The catalyst is ZnO and Cr2O3, zinc oxide and chromium trioxide. Okay, let's go for next question. 21. What is the 21 question, dear students? It is tertiary alcohol. It's very important. It is elimination reactions. Already we know that elimination reactions are two types. Okay, in acidic medium. Okay, in acidic medium, it converted into CH3 OH 2 plus and CH3 bond CH3 and loss of water molecule produce tertiary carbocation. This tertiary carbocation is stable and loss of H plus at beta hydrogen, any one of the hydrogen you have to remove. At beta carbon hydrogen you have to remove, then we'll get CH3 bond C double bond CH2 bond CH3. This is alkene. So this reaction is a E1 elimination reaction. E1 elimination reaction. Okay, so E1 elimination reactions order tertiary alcohols are more reactive when compared to secondary alcohols and then primary alcohols. Whenever E2 means primary alcohol is more reactive than secondary alcohols and then tertiary alcohol. Okay, just it is like SN1 and SN2 mechanism. SN1 and SN2 is substitution, nucleophilic substitution reaction. E1 and E2 elimination reactions are elimination reactions. In E1 elimination reaction, carbocation intermediate will forms. In E2 elimination reactions, transition state intermediate will forms. Now the given alcohol is tertiary alcohol, they can form stable carbocation intermediate, tertiary carbocation. That's why the elimination reaction takes place through E1 mechanism, through E1 unimolecular elimination reaction mechanism. So the answer is third one. Okay, then tomorrow we will discuss phenols objective. Okay, phenol properties, that objective we will discuss. Okay.